Okay, let's consider this problem here. ln of x square root of x squared plus 1. So it's ln of all that stuff. All that stuff's inside the natural log. So I'm going to do this problem two ways. I'm going to show you first how we can use our properties of logarithms to break this apart and get an answer. And then we'll turn around and do the problem without using our properties of logarithm. We're going to see that it's going to be a lot more complicated. I think we will anyway, in my opinion. But we'll see that we do get the answer, and it's good practice anyway to, trying to work through some of the algebra, doing it the long way, just for a little bit of algebra practice. So first, let's rewrite using our properties of logs. X square root of x squared plus 1 can first off be rewritten as x times the quantity x squared plus 1 to the 1/2. Those are being multiplied, so I can use my properties of logs to break that apart as ln of x plus ln of x squared plus 1 raised to the 1/2 power. Okay, and then that 1/2 power there, we can use our other property of logs to pull that 1/2 power out front. So that now, instead of having a product inside the natural log, where we'd have to use the product rule, we now have just ln of x, and we also have stripped away one of those composite functions, because now we still have stuff inside the ln, but that square root part, which we would have had to do the derivative with the 1/2 exponent, has now moved outside as a coefficient. And so it's made the problem maybe a little bit nicer looking. And now let's go ahead and do our derivative. F prime, derivative of ln of x, would be just 1 over x plus 1/2, and then we have to do the derivative of ln of this stuff. So the x squared plus 1 goes in the bottom. Derivative of x squared plus 1, which is 2x, goes in the top. And then we can do just a little bit of cleaning. The 2's cancel out. So we have 1 over x plus x over x squared plus 1. And we could leave the answer like that, and it's fine. Or we could put those together as a single fraction. So the common denominator here would be x squared plus 1. So the first fraction here had the x, but it didn't have the x squared plus 1. So we'd have to multiply with the top by x squared plus 1. So that'll go up there. 1 times x squared plus 1 is just x squared plus 1. The second fraction, the x squared plus 1 denominator, didn't have the x. So we'd have to multiply the top by x. X times x would make that x squared. And so then simplifying, we have our derivative 2x squared plus 1 over x squared plus 1. Or again, we would have been fine writing it as 1 over x plus x over x squared plus 1. Either one of those ways actually would be okay. Now, let's look at it the long way. So for the long way, we're going to first work out the derivative of the stuff inside. So in other words, we're going to work out the derivative of x times x squared plus 1 to the 1/2. Right? And doing that, we're going to have to use our product rule. So here's your challenge. Go ahead and maybe pause the video and do that, just for the practice of doing that kind of derivative. And so let's continue now. That would be the first x times the derivative of the second. So derivative of x squared plus 1 to the 1/2. We'd multiply by the 1/2. X squared plus 1. Drop it by 1 to the minus 1/2. Don't forget the chain rule. Times the derivative of the inside. Derivative of x squared plus 1 is 2x. And then the other part's pretty easy. Plus the x squared plus 1 to the 1/2 times the derivative of x, which is just 1. Okay, and then we just have to go through and do some simplifying. Notice here the 1/2 and the 2 are going to cancel out. The x's can come together to become x squared. And then I notice, hey, I have that quantity x squared plus 1 in both of them. So I pull out the smallest power, which is the negative 1/2. And so when we do that, we get x squared plus 1 to the negative 1/2. And then in that first part here, the 1/2s again cancel out, and we just have x and x, which is x squared. We're taking something to the negative 1/2 out of something to the 1/2. Remember, when we divide, we subtract exponents. 1/2 minus the negative 1/2 would be 1/2 plus 1/2. And so that's just x squared plus 1. So splitting that all together, we'd have 2x squared plus 1 all over the square root of x squared plus 1. That's just the derivative of the inside. Then we apply our chain rule with the derivative of ln of x. And we realize, hey, that's going to be that stuff divided by the stuff on the inside. And when you do that arithmetic to simplify, you will get back to that expression over here. Right? Because what will actually happen is you'll have that fraction times 1 over this stuff. So the two square roots come together to give you x squared plus 1, along with the x in the bottom. And so you can kind of judge for yourself which of those two ways was the easier one. Personally, I definitely think rewriting it using properties of logarithms by far and away much, much better. Didn't get into this messy chain product rule that we had to deal with this long way. Okay, so that's another example doing derivatives with the logs, and in this case, making use of our properties of logs to break it apart.